I've been playing with CVAT annotation tool recently. It's not a bad tool. CVAT is an open source annotation tool, so you can label data for your deep learning tasks. It's pretty decent. There's a few caveats though. The first one being any frames you haven't labeled still get exported in the dataset. So you've got all these empty frames missing, no labels attached to them. You also can't adjust the resolution of the dataset very easily. When you're working with big datasets and you're labeling long videos and it's high resolution, say you're going to train 1024 by 1024, it exports everything in PNG, which obviously you need PNG for deep learning because you want all that information to be in the image. But sometimes you're doing a task where you've got a lot of images, PNGs take a lot of space, you've got like 100 gigabyte data set, which is huge, but the object that you're trying to detect isn't that complex, so you don't really need the PNG. It's not that, you don't need that much information out of the image. It's quite easy to train it. So you don't need to waste all that space. You might be dealing with cloud training, uploading bottlenecks in your broadband speed, whatever. There's a lot of things that can come into play. So what I did was I wrote a few scripts to just automate it all. First of all, we've got a little PNG to JPEG script here. You plant this script in any folder and just run it in a command line, open a command prompt in that folder, run it. It'll convert every JPEG in that folder every PNG into a JPEG. It's non-destructive. All my scripts are non-destructive, so your PNGs will still be there. It's up to you to move them or delete them or do whatever you want with them. Very simple script. It does require CV2 and TQDM to be installed. Now I know it's not best practice to release scripts that don't use standard library and all that sort of stuff for minimal tasks like this. However, as a coder who works with deep learning all the time and graphics and all kinds of things, I've always got CV2 installed on my default installation. I've always got TQDM installed. I've always got multitude of things installed on my default installation. That's the way I like to work. I've got all the latest versions, stable versions of things installed as default, so it's not a problem for me. Okay, now before we move on to the scripts to edit the dataset, bear in mind that this is for a COCO V1 dataset. Okay, everything here is optimized for COCO V1, and that's what I export my datasets as, because eventually I convert them all into TF records as well. Yeah, so the resolution converter first we'll have a look at, will we? No, let's look at this one. Okay, so remove empty annotation files. This is going to go through and get rid of any images that are unlabeled and any labels that have no image counterparts in the folders. So this is the input data set here. We've got our original JSON file and all the images. Remember, we're using CVAT COCO V1 dataset. That's what it is. It's been exported as a COCO V1 dataset. So image directory input and the annotation file, that's all we need. It's going to go through, it's going to sort out all the images and annotations, get rid of anything that's not being used. It will move the images into a trash folder, _trash, if there are any, and it will create a new JSON file next to your original JSON file. So let's give this a little whirl. We're going to remove empty files. We're going to go input data set, and we're going to check up here, make sure we're getting the right stuff. So there's an example at the top here, so you just need to put in your path. That's the input path, and then we need the images, input data set, annotations, instance, default, JSON, boom. There we go. It's found a load of JPEGs that don't exist, so the annotation was removed. There's no images being removed, so that's good. We've got the new annotations here. Now, something I must remind you, because I've already done this, when you convert all the images from PNG to JPEG, you've got to make sure you go into the original JSON file before you do any further things, and you do a find and replace for PNG to JPEG, okay? And replace every PNG to JPEG in the whole file, okay? Because you can see here, all the file names end in .jpg, but when CVAT exports it, these will all be .png. So if you convert the images, make sure you go into the JSON file and do a find and replace, and make sure you update it, okay? So that's that done. Remove any empties. Okay, cool, nice. Let's go and change the resolution, shall we? Boop, 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 boop. Right. Let's give it a new resolution. Pi, convert, COCO resolution. And we've got our input data set images. We want to resize it, so we're gonna send it to output resized, and we want the input. I should have put both inputs first in the command in the arg parser, really. Why didn't I do that? And we want the new annotations JSON, and we want a resolution of 800 by 800. Yeah. Let's see. Now this should also draw an example image at the end of it. Okay, so that's finished. Let's have a look at the Resize data set here. Oop. And there you go. It has resized it for me. Perfect. So the resizing is complete. That's all in here. Annotations, images, lovely jubbly. What I also have is a split dataset script. So this will split the dataset in between training and validation for you, in case you don't label them separately and you want to split them. I don't really do things like this in production because your validation and your test dataset should be different to your training one. When you're labeling videos and then you just split the data set, you end up with loads of frames that are similar to training frames and test frames. They're all very similar. It's not a good idea. You want to have completely different videos. Your validation set wants to be different to your training set, but not too different that it's so difficult, right? Your test set wants to be completely different from the validation and the training, okay, to get a real accurate real world idea of what's going on. So bear that in mind. However, if you do need to split the data set, this script will split the data set and output it. Let's split the data set. We've got our splitter here, takes in the annotation file and the image input and the output folder, I believe. Let's have a look-see. Yep, so again, let's pi split CVAT COCO, and we're going to use output resize as the input this time. Your annotations adjusted, and the output is going to be output split, and the split ratio is 0.8 by default, so we'll just do that. Boom, really quick. Let's have a look. Here we go. Annotations, train JSON, val.json. Yeah, train and val images. And what we can do is we can go play labeled image sequence. So I've also got a script here so you can play a labeled data set, right? You just run this script, give it the input, the image folder as an input, the annotations file, the format of the images, whether it's JPEG or PNG, and you can specify a frame rate as well. I believe the default is 25 here. So that'll just play a labeled data set with the bounding boxes on it. They'll all be the same color. It's not going to change colors for different labels. It's just going to show you that it's been done correctly. We'll go up to the command example here. So play labeled image sequence, and the input is output split images, and the annotation is output split annotations, and we're going to do, oh sorry, my bad, train, and then annotations train.json, and it's JPEG, and we want to do it at FPS 60, and let's go. Here we go. all working. Lovely. Perfect. Yeah. So that all works. And I've also got to include this little script, which is image to MP4. Very simple script. Takes in an image dir, an output directory and a file name. You can specify width, height and frame rate as well. And this will take in, so say what happened was, the reason I created this script was because I actually made a sample data set to demonstrate these tools. And I made it a little while ago, and then I finally got around to sorting out this video. I found that I deleted the original video that I labeled the data set from, so I didn't have it anymore to play it for you. So I quickly wrote a script and I know I could have just got the images, chucked them in DaVinci Resolve as an image sequence, exported the video and all that, but I'm a coder, so I wrote a script so that I could just run it in the future if I ever need to do this. Pretty handy. Just take the images out your folder, put them into an MP4 and export it. Simples. Alright. Image to MP4 and we go output. No. We want the actual input data set with this one. We want the original data set and we want to output it to dataset video and we're going to call it example.mp4 with a width of 1920 and a height of 804 because the original resolution was 3440 by 1440, which is a 2.93 ratio, aspect ratio. And we'll see what happens. Okay, that's done. There it is. There's the video. Beautiful. Avenging my teammate, because that's just the kind of guy I am. Okay, so this script, the create COCO TF Record sharded. I found this somewhere, or whether it was in a guide or it was uploaded somewhere, of how to make sharded TF records. Sharded TF records are just your data split up into multiple TF records, okay? Because sometimes, like, you might have TF records that are gigabytes and you might be using a cloud service or your local GPU and it might not be able to handle that size of TF record in the cache or wherever in the RAM, so you split it up. Okay, so that's simple. If you've got a 10 gig data set, you want to split it up. Generally, the rule of thumb, you don't want TF records to be more than 500 megabytes a piece. Keep it low. So you just specify how many shards you want it to be split up into, depending on how big the data set is, right? And yeah, so that's shard number here. I couldn't find this script anywhere to know where I got it from or what I changed about. I can't remember what it was. I know I changed something, but I don't know what I changed. I can't remember. It's been a while. So I just thought I would include it and upload it in case anyone needs it. Right, to show you the COCO TF Record sharded file working, remember you need to have the TensorFlow 2 object detection API set up. I've got the object detection folder in this directory here. I've got it all set up. It's a bit tricky on Windows, but it's doable. So I'm going to run it from here, create sharded TF record. Now the command for this is really annoying because you have to type out all the flags, which is rather annoying. We're going to do it as such. So train image directory, copy path reference, copy from content root, yeah. Test image and number of shards of shard num, so we'll say 5. Oops, 52, don't want that, and enter. Please work first time, please work first time, please work first time. Test annotations file. Did I do it? See, test annotation file. It just naturally, why would it be annotations? Okay, There we go, and we're done. Yeah, so output TF records now. Boom, there you go, test record, train record. Now, in case you're wondering, when you do these sharded files, you want to specify it like this in the pipeline configuration, yeah? So if you've got a train record hyphen question mark question mark question mark question mark question mark question mark of, and then 00015, because I had 15 shards. Here would you put 00005. Okay, that's what you would put there. So that's how you specify the sharding as data, and then it will go through all of those shards. It will know what you're talking about. Okay. Just a quick word. I've used type hinting in this repository purely to be explicit, so everyone knows what's going on. Just something I felt like doing, and it avoids confusion and avoids people asking me lots of unnecessary questions, because they can see clearly what's going on. You've got your description here of all the parameters. You've got it spelled out for you here. Personally, I'm not into using type hinting in Python. Python is supposed to be easily legible. You should be able to just look at it and know what's going on. And to be fair, if I took away the type hinting here, you would look at it, and because of the names of the parameters, you would know what's going on. You wouldn't even need this description here either. But I've just been extra because I'm putting it up to a repo, and lots of people might see it, and you might not know what's going on. You might want to edit it, do something to it. At least you know exactly what's happening, like that. All that information there. Okay, so that's why I've done that for this. Okay, we're going to have a little code review now. I'm just going to walk through certain bits of code in case you want to have a look at what's going on under the hood. If not, you can just skip this and go straight to using the toolset. So we're going to start off with the PNG to JPEG. Pretty simple stuff, straightforward. As I said before, I've got CV2 and TQDM as standard in my installation. We get the current working directory here, and we store it in the input variable that we use to then walk the directories. Now, I've put these few lines in here for you. os.walk goes through all the subdirectories as well. So this will convert every PNG file into a JPEG in the subdirectories as well. So if you don't want that, then what you have to do is uncomment these two lines, comment these two out, and just set this back. Okay, and using lister, we store all the files into an array here, and we run through them down here. Okay, now I'm going to leave it as a walk because I like that functionality. I know where I'm placing the file. Down here we're doing if image file .lower ends with PNG. The reason I'm setting the file name to lowercase when I'm checking it, because sometimes the extensions are in capital letters, so I just standardize it. I always put everything to lowercase when I'm gonna check the extension and things like that. And then I just build the dir path plus the image file here. We get the dir path from walk in the directory. We use CV2 to read it, and here the file name, I'm using rsplit. This is one method to split strings. What I'm doing here is image file .rsplit. And I'm saying that the full stop is the separator. So the first parameter you pass into rsplit is the separator value, which means that when it reaches a full stop, it will split the string. And the second parameter is the maximum amount of times to split the string. So because I've set max split to 1, that means that once it reaches the first full stop, it will split the string, and that's it. And what that does is it returns an array of the splits. So here I'm accessing the 0th index of the array, which is the name. If this was a 1 here, then I would be accessing PNG, okay? But I want the file name. So I can show you how this works here. We've got image file equals image.png, so that's a string. File name equals image file.rsplit, separator full stop, max split 1. Let's take this bit off here, yeah? And just run that. As you can see, it says image PNG, it's an array. So if I go file name 0 image, yeah, the 0th index, and if I choose the first index, PNG. Okay, so we just tap that onto the end there in one line, and then we don't need to bother. we get image still, yeah? So that's what's going on there. And on this line here, the image write needs to be fed the file name and its path. So I've got the dir path, file name, and .jpeg at the end, plus the image itself that's being saved. And here we have an array, and in this array what you do is you specify the value here and what the value is for here. Now this is a safeguard. I've wrapped this as an int. This doesn't even need to be wrapped as an integer, because this is a built-in CV2 parameter and it should come back as an integer anyway. It's just me being extra. What I'm saying is the JPEG quality should be set to 100 so that I don't degrade the quality when I save it out to a JPEG. Okay, and that's the PNG to JPEG. Right, the image to MP4 script now. In case you don't know anything about arg parsers, this is so you can take commands in the command line. And the way it works, so here we've got these are positional arguments and these are optional. The ones with the 2 dashes here, the 2 hyphens in front, they're optional arguments. And you provide a default here in case the person doesn't type in the option. Now, these positional arguments, you don't need to type in the command, you don't need to type input dir equals or anything like that. You can just type the input dir in, type the output in, type the file name. You don't need to specify the option like you would here. Because with these, you'd have to type -- width and then the width, right? So what a lot of people make the mistake of doing is they'll go like this and go -- input, they'll make everything optional like that, and then they'll have required equals true. Well, there's not much point in that. If it's required, just make it optional. Just make it a positional argument, because then you don't want to have to type all these things out for no reason when you have to put them in anyway. And then to get the arguments from the arg parser, I made this a function here. It doesn't have to be a function, but I've passed arguments, and what the real function called is to get the arguments is parser.parseargs, okay? And that's what I'm returning the result of that call to here. And then you could just access the arguments. args.inputdir will give you the input dir, args.output, it's a dictionary. So then I make dir here, make sure the output dir is created, and if it exists, not a problem, won't cause an error. Output file name, if the file name, the args.filename ends with MP4, right? Because if the user could either type the full .mp4 file name, or they could just type a file name without any extension. If it doesn't have an extension, then put the .mp4 on the end of it. Yeah? Then we have the frames per second, the height and the width pulled out of there. And then what we need to do is create a codec. So the full CC MP4V, so you can write MP4s. And then here we've got the video writer we're setting up to write the video, output destination, the codec, how many frames per second. Now remember, output destination, we've included the file name, right? So it knows this is the path plus the .mp4. Width and height, and true here, there's a parameter here called isColor. So if it's a color video, you put true. If it's not, you put false, okay? Process the images. So this is using listdir. We're not going to go through the subdirectories because we're making a video of images. If you have subdirectories and you start going through them all, it's going to be a right mess. So listdir, get the files. We check that they're PNG or JPG first before we start even trying to process it. We process it. We resize them to the desired width and height. We convert the color from BGR to RGB. And then here we're actually in writing the file. The writer needs an array, a NumPy array. So we pass the frame into that. We create a NumPy array. And here we're using some slicing to flip the color. Yeah. So the way that slicing works is you have a value here and a value there, and you can also have a value there, right? So let's say that what this would be is the beginning of the slice, the end of the slice, and the step. So 1 would be every file, 2 would be every second file or every second piece of data, every second index in the array, yeah? 1 is default, so you don't need to specify it. If I don't specify an end and I don't specify a start, then it means all the data. Okay, so I'm just saying everything. So So this is actually width, height, and color. So we want all the data from the width, all the data from the height, and here, well, here there would usually be 1, 2 numbers, right? There's no end, there's no start, so all the data, but this is the step value. And if the step value is -1, then it's going in reverse. So what this does is simply flip RGB to BGR, right? So that you can write it out because the writer expects BGR. Yeah, so then we increase the frame count if it's successful, we release the writer at the end, and job's complete. We've written the file because we're doing this for each file, right? Each file becomes a frame. Now, did you notice anything there? Are you paying attention? Up here, I switched the color from BGR to RGB, and then I flipped it back again. So these two lines are actually redundant. All I really need to do, because the OpenCV frames are already BGR, right? I don't need that. I don't need this either. All I need to do is pass the frame in. Okay? Just a little brain teaser to keep you awake and while you're watching, paying attention. So there you go. That's the image to MP4 script. Right, now we're on to the convert resolution of the COCO dataset. I've got everything in different functions here. We've got a resize images function here. We've got an adjust annotations function here. Draw bounding boxes to present the sample when we're finished. And here I've got the arg parser. Notice here I haven't got the arg parser in a separate function. It's just there. It's just parser equals argument parser. So I just do the parser.parseArgs. You know what's going on here. I just explained it to you in the previous section. We've got our positional arguments and an optional one. Okay. Again, we check the directory exists. If there's no input directory, we just exit with an error because we can't do anything without an input directory. Same thing here if there's no annotation file, right? We set up the directories for the outputs, images and annotations. We go through the resize images. We pass args.resolution in there, args.input.dir, and the images output.dir. Yeah, resize images. Here we're taking in the resolution, the output and the input. We're gathering the files, list.dir. Remember, we don't want to go through subdirectories with os.walk. We're using os.list.dir. File for file in list.dir, input.dir, if it is a file. Okay, and we check that it's an existing file. So for each file, now in this TQDM, I've actually put a description this time saying resize images. You don't have to put this parameter in there. It's optional. It's just so that it writes a little description above the progress bar. So again, we check that it's PNG JPG before we do any operations. Very simple, cv2.resize, and then save it. Same for adjust annotations. The annotation file comes in, output.dir, resolution. Yeah, same thing here, output file, output path. This is the other way of getting the name. You see before I used rsplit, here we've got os.path.basename will give you the file name. So this is the original annotation file, and I'm getting the 0th index again, which is the file name, not the extension. And then I'm adding a suffix here, underscore adjusted.json. So that will be the name of the new JSON file will be the original file's name plus this suffix. Make the dirs, load the JSON data, yeah, into COCO data, into this dictionary here. And then we TQDM COCO data images. So we're going through the images portion of that JSON file, right? We're saving the image IDs, width, height. Yeah, we're extracting them out. And then what we're doing is we're getting the desired resolution, the width and the height, and we're dividing it by the width and the height here. So we get our scale factor. Yeah. And then we go into the annotations. We check that it's the right image. We find the image we're working on. We get the bounding box annotation, and the bounding box annotation is XY and width height. Yes. So we multiply them by the scale factor. We update the size in the COCO annotations. We replace it basically, the new resolution, and we save it out, and that's that done. And once those have all been done, we'll call draw bounding boxes. But remember, we're going to call it here on the output dir and the output annotation is the stuff we've saved. We want to test the stuff we've saved. So again, we load the JSON file of the new annotations, we go through them, we get the image IDs and the annotations, we go through it, and we pick the first one. We only do one here, right? For each annotation, so for annotation and annotations, we get the bounding box, yeah, from annotation BB box, x, y, width, height equals map int B box. Now what this means is map int B box. The map function means that it will go through the B box array, and every value inside that array, it will apply the int function. What that int function will do is turn every float that's in the bounding box into an integer, okay? So we just do that, and we get our integer version of x, y, width, and height. The reason being is CV2 rectangle requires integer, okay? And I've put this explanation here for you so you know what's going on. The x and the y are the top left corner of the box. X plus width and y plus height is the bottom right corner of the box. So it goes like that, whoop, whoop, yeah? And then you get the, whoop, like that. And the color here, standard RGB value. And this is the line thickness of the box itself, how thick the line is. So you just plug those in there with the image that you want to draw the rectangle on. We use cv2.image_show to show that it's been completed. If it's successful, we're done, we're good to go. So that's the resolution conversion. Right, onto the splitting of the data set. Here we have, I've done it a bit different again. I've got the arg parser in a function, I've got the split data set in a separate function, and the save files and move images, and the validation function here, okay? So in my main, once again, we're getting the arguments, arg parser, and we're creating all the output directories. This is the file structure for a COCO dataset, because this is going to be made into TF records. So this is the file structure you need to input into the script that creates the TF records. So once again, data images, data annotations, we're taking the JSON data out of the annotation file. We're creating a set of image IDs. The set function, it's like a list, but it's unique values only. There's no repeats, so you get a unique values only. You don't make any mistakes by having repeated entries. So I use set for those things. It's also much faster and more memory efficient in particular cases. So when you can use it, use it. We shuffle the image IDs because we're shuffling the images because they've all just been put in one pot. We're going to shuffle them before we split them. Pretty standard stuff. Split IDs. Here we're getting the split ratio that we've entered, or is by default 0.8. So you have 80% training and 20% validation, yeah? So what we do here is we multiply it by the length of image IDs, which is obviously you're getting 80% of the image IDs. And then we use slicing rather. And as I just told you about slicing, positional, this is the end and this is the beginning, right? So we're taking 80% and then we're starting at 80 and taking the remaining 20% here, right? So the validation is the remaining 20%, training IDs is the first 80% of the data set. We're using sets to make sure we're not repeating any IDs anywhere. And now with the split data set function that I made, that returns training images, validation images, annotations, right? So we have a look at this. So we send in the list of images, the annotation list, the training IDs and the validation IDs, right? And we do it image for image in images. If image ID is in training IDs, then we add that image to training images. If the image ID is in validation IDs, we add it to the validation images. Same for the annotations. If the image ID in that annotation is in training IDs, it goes into training annotations. And then we send it back. Now when we save and move images, right, what I've done here is made a for loop, and I've created an array in the for loop to go through. So it will go 1, 2, right? It will do this one first. It will pass these parameters first into the save function. Train images, train annotations, train, and train.json. This is the name of the folder that the data is going to be saved into, the train folder and the val folder. So it'll go 1 and run save files and images with data. This is the original annotations JSON that we loaded, the original image set, image list, annotation list, folder, file name, args source image dir, and args output dir. Yeah. So that goes in, moves all the files that it needs to move. Yeah. From that's why we have the source, the original dir, and straight through there. Same with annotations, which is why we also have the output dir as standard for both. So then we can just create the folders afterwards. We build the JSON structure here for COCO dataset, and we export it to the JSON file. And then at the bottom, we validate the split by calling, of course, all the outputted annotations and images we've just saved. Yeah, because we want to validate the split. So this will come in. I've got a little flag here saying success equals true, because if it fails anywhere here, I'm going to put false. All right. So it's going to go through, it's going to check that it's got all the keys. If it has missing keys, it will print it out and set success to false. Image IDs, and then if there's any annotation IDs that don't correspond to an image, then that gets printed out as well. It checks if all the image files exist, and if any don't exist, it tells you that as well. And obviously, if there's a failure, there's a failure, and we raise an exception. Otherwise, we print successful. So that's the splitting of the data set covered. Right, play labeled image sequence now. Once again, arg parser, input the annotations, format, and the FPS. Yeah, we've got, this is the main function here, just two little functions, the arg parser and then play image sequences, and I pass in everything from the argument parser. All right, so play image sequence. I've got this is type hinted and this one isn't, because I actually separated this later and made it a separate function, and this was never intended to be released for anything, but I thought I'd just throw it into the GitHub repo anyway. So play image sequence, again, image files, list, must be getting used to this by now. This one is sorted because the data sets, if you've taken a video generally and made it into images, or you've generally got it numbered, so the frames want to be in order, so I sort it. Again, we check that the image format, whether it's JPEG or PNG that you've specified in lowercase, matches the file, so we know that it's a correct file type. There's no images found, we exit. JSON, load the JSON data. We create a dictionary, once again, the image ID and file name. So that's a key value pair for each image inside the annotations data images portion. We take the ID and the file name. Then we create a directory mapping from the image file name to the annotations. So for each annotation within the annotations section of the JSON data, we check the image ID. If there isn't one in there, what we do is we make it and then append it. Okay. So for each image file, in the image files, we're reading them, we're drawing the annotations on it. Yeah. So that's this function here. You know about the cv2.rectangle, I've just explained it. And here, what we're doing here in this P, you might not have seen this in cv2.wakekey, but this integer here is so that whatever FPS the user passes in, whether it's 30, 60, 120, if you divide 1000 by it, what you get is the millisecond value of how long that image should stay on the screen. So if I say 30 frames per second, I'll get 33 milliseconds per image on the screen, which will create a 30 frame per second video. Okay. And if you press Q, it closes the window and it's done. All right. So that's the play loaded image sequence. Right, the remove empty annotation files. We've got the arg parser here, load annotations, save annotations. Very simple. I've just wrapped these in functions to make it a bit more tidy down here. So in the main function, as usual, we get the arguments from the arg parser, input directory, input annotation file. We load the annotations. We create an image dictionary of key value pairs of image ID and image file name for each image within the annotations/images portion of the JSON data. And then we create a set of image IDs that have annotations. Okay, so annotated images, for each annotation in the annotations, we take the image ID, right? Because that's the ID of the image that has an annotation. And then to create a set of unannotated images, we use the set function, and we get the image dictionary dot keys, which is all the image IDs. That's the keys. These are the values. Okay, so we get all the image IDs here, and we subtract all the annotated image IDs from that. So all you're left with is image IDs that do not have annotations. Okay, and then down here, what we're doing is we're going through each image ID in unannotated image IDs. So anything that doesn't have an annotation, we're going through it. We're getting the file name from the image dictionary using the ID, right? So now we're getting the value, we're getting the file name, this here, and we're checking whether it exists or not. Okay, if it exists, we append it to this list. If it doesn't exist, we remove it from the annotations. Okay, then we save the new annotations. Now, if there's any images in this existing unannotated image files list, we go through it and we move them to the trash folder. Okay, and then we're done. Nice and clean data set. Now, as for the create sharded records, because this was originally written by the TensorFlow team for the object detection API, I'm not going to go through the whole thing. What I will go through is just what changes were made. We've got a flag here for shard numbers. Okay, so you specify how many you want. I've put a default of 15 in there. It's generally my default go-to. I mean, I haven't used this for ages. I've moved on to different platforms and tools now, but there's a flag in there, and then there is, yes, so this is grayed out because I'm actually redefining this somewhere else. Here, TF record creation util dot open sharded output TF records. Okay, and here's where I'm putting the number of shards in there. And then down here, instead of using what was originally there, output TF records dot write, I'm using output records with the index, the shard index dot write. Okay, and again, shard number of shards must be greater than 0. Shard num. That's all the changes that have actually been made to make it do sharding. And that's a wrap. I hope this is helpful to you. It was definitely helpful to me. These scripts have helped me. I use them regularly. There's a couple here that I'm probably going to throw in another repo of just general file tools. You know, the PNG to JPEG, the MP4, the image to MP4, things like that. They can be thrown in with other file tools I've got, but lots of other tools to release, because I'm always automating things, always writing little scripts to help me do my daily chores. So yeah, stay tuned. Thanks for that. Have a good one. See you later.